So let's start. Today I'm gonna solve the assignment problem that had been given in the previous year, week 5. So let's start with the first question. So first question is given as question 1. Question 1. So question 1 is, let U be a uniformly distributed random variable on the interval 0 to 1. And if be an absolutely continuous CDF cumulative distribution function of a random variable x, then what distribution f will follow. So that is the question. So let's solve this question. So x is a random variable and its cumulative distribution function is f. So now our redefined random variable will become f of x. So now let's define our random variable y equal to f of x, and we know from the property of f of x, cumulative distribution function, we know that this fx belong fx, the value of the fx is in between 0 to 1. So this fx lie in between 0 to 1. Now we have to calculate. Suppose we want to f of x. Now we want to calculate the cumulative distribution function of this y's. What will be the cumulative distribution function? So suppose that cumulative distribution function gx, this means the probability that y less than small x. Okay, so this means probability of f of x less than small x, and here this x, hence x means this y, and y this x should belong between 0 to 1. Okay, so f of x less than x, so that means probability of x less than to f inverse of small x. So you can write that. Now what does this means? Probability of this x less than this means this is actually a CDF of, this is nothing but the f of f inverse x, because we know the CDF of this random variable capital X is nothing but f, and this probability that capital X less than or equal to f inverse x or something, suppose what is the CDF f of x means f of suppose x equal to a, if x is equal to a is nothing but probability that x less than equal to a. That means here what is this? This means the cumulative function at the value f inverse x, and we know that f inverse x is nothing but small x. So we get that what is the cumulative function of this random variable y equal to fx is x, and uh, for x greater than 0, what will be the value? That means what is the x greater than 0? Fx is p of y greater than 0. It is not possible, so this is probability is 0. And for x, sorry, this is not x greater than 0, this is x less than 0. And for x greater than 1, gx equal to p less than 0, so p greater than 1. So this is also not possible, since this cumulative distribution function should lie between 0 to 1, so this is also 0. Now we'll get the cumulative function of the cumulative function of this variable fx, or cumulative function of another variable, is same as the uniform distribution. So that means this fx follows randomly these follows a uniform distribution, and which value that's random variable, the value of that random variable lies between the interval 0 to 1. So that means the result is fx and u, fx and u have the same distribution, have the same distribution. So that's it. Now you get my point. So we know that this is my cumulative distribution function, so you easily calculate what is the probability distribution function pdf will be simply 1. So what will be the fx? Simply 1. And for the uniform distributed random variable also the pdf is 1, and the cumulative function is x. So that means these two distributions are same. So that is the first question. Now let's go toward the second question. Okay. Second question is as follows. Question 2. Question 2. Let x be a normally distributed random variable. Distributed random variable with mean 0, and variance is 4. Then the distributed distribution of y equal to x plus p, where a not equal to 0 and belongs to it's a real number, and b also not equal to 0 and belongs to a real number. So to calculate what is the distribution of this. Okay, let's see. So first of all, for getting the distribution, we have to calculate the CDF. So what is the probability that y lies between, suppose CDF, this is, look at it, what is the CDF? Gx will be probability that y less than equal to x. So that means probability of ax plus b less than equal to small x. So that means probability of ax less than or equal to small x minus b by a. This is nothing but the cumulative distribution function of the normally distribution function at x minus b by a. And what is the cumulative distribution function of this normally distributed function? So let's see what it is. So let calculate. Let's see. So this is the that. Now then, what is the cumulative distribution? What is the PDF? PDF will be nothing but the derivative of this. So f of this new random variable y at x will be differentiate with respect to x, g of x. So this is t dx f of n x minus p by a. So this is f n prime x minus p by a, or this is, suppose this let suppose that z equal to x minus p by a. So this is actually dz of f n z into dz dx. So dz dx will be 1 over a into this is again, this is a normal, this distribution is this is the cumulative function of the Gaussian distribution. So the derivative of the cumulative distribution function will be again the same PDF as the normal distribution. So it will be fx at z. So this is 1 over a. What is the fx? So it has been given that the mean is 0 and variance is 4. So that means this is nothing but 1 by variance is 4. Variance is 4 means sigma square, standard deviation square, equal to 4. So that means sigma equal to 2. That's it. So this is, let this is will be sigma root 2 pi e to the power minus half z minus mu will 0. So this is z minus 0 by 2 its square. So this is 1 over a into 1 over 1 by 2a into root 2 pi e to the power minus half this is x minus z means x minus p by a, so x minus p by 2a square. Now you see this is again, that means the distribution of this y is again a normal distribution, right, with sigma equal to 2a and mean equal to p. So x minus mu, so this is in the form of normal distribution with mean b and standard deviation 2a. So the right answer will be it is a normal distribution. So it is a the distribution of y is a normal distribution with mean b and standard deviation is 2a. So that is the answer. So now let's move toward the next question, third question. Question number 3. Suppose, excuse me, suppose xpa normally distribution random variable, xpa standard normally distributed function. So that means x follows normal distribution with mean 0 and standard deviation 1. That means the PDF will be 1 by root 2 pi e to the power minus x square by 2. So this is the PDF. Now we have to calculate what is the probability that x greater than 0 where x is equal to 1. So given that, and the meaning of this saying is nothing but this is mean equal to plus 1 if 1 greater than x less than 2 and minus 1 if minus 1 greater than x less than 0. Now let's calculate the probability of these is 1. So this is nothing but probability of these, modulus of this means these two region also include less than x less than 2 plus probability of minus 1 less than x less than 0. So this is the cumulative distribution function of the standard normally distribution is phi 2 minus phi 1 plus phi of 0 minus phi of minus 1. So this is, and at phi 0, if we put phi 0, this is 1 over root 2 pi. No, not root 2 pi. So phi 0 means the cumulative function at 0. So this will be half, right? Nothing but half. And we know that phi 1, so phi 0 means, since we know that normal distribution function is symmetric about its mean, and here for standard normal distribution mean is 0, so what is the cumulative distribution function value will at 0. So this is nothing but the sum of all this region, and we know that from the sum of all from minus infinity to plus infinity is 1, and since it is symmetric about 0, so the sum of this probability or cumulative distribution function of only this side should equal to only this side, 0 to infinity. So that means cumulative function at 0 should be half, because half of the regions are covered. So that means phi of 2 plus half and minus phi of 1 plus phi of minus 1. And we also know that phi of 1 plus minus 1 is 1. So that is phi of 2 plus half minus 1. So this is phi of 2 minus 0.5. And given that when these both condition will satisfy, that x greater than 0 and this is equal to 1, so both will be satisfied when it lies in this region. So that means probability of x this, so this is nothing but phi of 2 minus phi of 1. So, and this is a okay, let me that Bayes theorem, right? Bayes theorem or conditional probability, apply the rule of conditional probability. So this is nothing but equal to probability x greater than 0 equal to 1 divided by probability of this equal to 1. So put the value, if we put the value that this value is phi 2 minus phi 1 by this is phi 2 minus 0.5. So this is it. So this is the solution for the question 3. Now let's move toward the question number 4. Okay, question number 4. Question number 4 is the probability that a patient recovers from a blood cancer is 0.2 if 200 people are known to have contracted this disease, then what is the probability? What is the probability that less than 50 survive? So it's actually a binomial problem, but as you see these numbers are quite high. We can use normal approximation. Can use normal approximation. Normal approximation. Normal approximation to the binomial distribution. Now we have to first know what is the mean. Mean will be n into p. Here's a sample size into probability of occurring a single event. So that is 200 into 0.2. It is 40. And what is the standard deviation? Standard deviation variance of x. Variance of x again, npq. Here np into 1 minus p, so that is 200 into 0.2 into 0.8. It is 32. Now we have to calculate what is the probability. Let's see, that we have to calculate probability that the random variable x is greater than or equal to 50. That means you have to calculate 1 minus probability of x less than equal to 50 plus probability of x equal to 50, but since x distributed normal and continuous distribution function, so this is 0. So 1 minus, so let go towards let's convert this variable to the standard normal distribution. So x minus its distribution 40 by root 32 less than equal to 50 minus 40 by root 32. So 1 minus, so this is so let move towards. Okay, so what is the word that less than 50 survives? Sorry, so this is not greater than equal to, so this is actually, this is less than 50. So this is, so less than 50, this will be, let me write it, this is probability of x less than equal to 50 minus probability of x equal to 50. So this is 0, and we can convert it to the normal standard normal distribution. So this will be probability of x minus 40 by root 32 should be less than 50 minus 40 by root 32. So this will be probability of x minus 40 by root 32 less than equal to 10 by root 32. So this is phi approximately this value, since this is a standard normal distribution, so phi less z, this is z less than, okay, this is phi at 1.7678. So this value is 1.7676. So this is that's it. So this will be, this is 0.96145. That is the probability. And here the z is, z means this variable is normally distributed 0 to 1. Now let's move towards the question number 5. Yeah. So here it is asked that the time until a recharge battery, okay, let me write it. The time until a recharge battery in a laptop computer under common condition the common conditions is normally distributed with mean of 260 minutes and standard deviation of 50 minutes. What is the third quartile? What is the third quartile of battery life? That means we have to calculate what is the probability that x less than equal to Q3. This is the value of the third quartile such that this probability is 0.75. So that means we can x minus mu, so x minus mu by sigma less than equal to Q3 minus mu by sigma should be should be 0.75. So we know that this is a variable becomes standard normal distribution. So that is phi is the cumulative distribution function of the standard normal distribution Q3. Here it has been given mu is 260 minute and sigma is 50 minute. So that means Q3 minus 260 by 50 is 0.75. And we know the value at which the standard normal distribution becomes 0.75, that is q3 minus 260 by 50, if this become 0.67449, it will become the probability, the cumulative distribution function up to this point is 0.75. So that means this equal to this. So from here we can calculate q3 is 50 into 0.67449 plus 260, which is 293.7245. So it basically means up to 75% of battery will that means 75% of batteries have the life of 293.7245 minutes. So that's it. Now let's move toward the next question, that is question number 6. Suppose ZPA standard normal distribution and let y is maximum of z and 0, then what is the which one of the following is correct? So the options are A, y is a discrete random variable, or B, y is a continuous random variable, C, y is not a random variable, and D, y is a mixed random variable. Let's see. So it has been told that y is greater than 0. That y is the maximum of z. Z is a normal distribution, so that means the value of z can take minus infinity to plus infinity. So now, so this y, the value of the y will be 0 if z less than 0, less than or equal to 0, or it become z if z greater than equal to 0, greater than 0. So this is the because less than if z become negative, if the z become negative, then 0 will be always greater than the 0 always be the maximum among z and 0, and if z is greater than 0, that means this. Now that means in this region, in the if z greater than z, so this is z, basically this z will follow the same standard normal distribution, but if z less than 0, the probability is 0. So that means the probability the cumulative distribution function in this side will be half and in this side this will be a normally something like that. Okay, let me do it properly. So these the variable y look like, so if this is z, then y will be 0 in this side, and if it is y and y equal to z, like this like a variable. So now you can see this is a mixed random variable, where for z less than 0 this is a discrete random variable, and for z greater than 0 it is a continuous random variable. So this is a the option D is correct. This is a mixed random variable. So that's it. Now let's move toward the question number 7. Question 7. Here it is asked that the IQ level of a group of student is assumed to be normally distributed. With mean 1 on 0 and standard deviation is 10. Then the probability that a random variable, the probability that randomly selected student has an IQ of at least 110 plus k is 0.05. Find the value of k. So we have to find the value of k such that only 0.05% 0.05% of the students have the IQ level above 1.110 plus k. We have to find here the random variable x is the IQ level, and it is distributed normally. So we have to calculate what is the probability that the x is greater than equal to 110 plus k, at least k. So this is nothing but 1 minus of probability x less than equal to 110 plus k plus probability of x equal to 110 plus k. As x is a continuous function, so this is 0. So that means 1 minus probability of x less than equal to 110 plus k. Now this we can write as x minus, so we actually convert this random variable, normally distributed random variable, to standard normally distributed random variable. So this is 110 minus, what is the standard deviation is 10, so less than equal to k plus k minus 1 on 10 by 10. So sorry, these will be only 10. So this is nothing but minus cumulative distribution function of the standard normal distribution at k by 10. Now it has been said that this value is equal to 1 minus phi k by 10 is 0.05. So this means phi k by 10 is 0.95. So at which value this cumulative value of the cumulative distribution function is 0.95. So from this table we get it k by 10 is equal to 1.64. so that means k becomes 16.4, and what will be the value of k is 16. So you will get 16 means no, you will get the IQ above 110 plus 116, so that means 126. So only the 5% of individual will have the IQ level above 126. That's the answer. Now let's this is the that now let's move toward the next question, that is question number 8. The diameter of a dot produced by a printer is normally distributed with mean diameter of 0.005 centimeter and standard deviation of 0.001 centimeter. Then what is the probability that a diameter is between 0.004 and 0.006. So here it has been said that x follows a normal distribution with mean 0.005 and standard deviation 0.001. So we have to calculate what is the probability that this x lies between 0.004 again 0.006. So this is probability. So we again take it to the standard normal distribution, since x is normal distributed. So this means that 0.004 minus 0.005 divided by 0.001 x minus 0.005 by 0.001 less than 0.006 minus 0.005 by 0.001. So this is probability of, if you, this is minus 1 less than equal to x minus 0.005 by 0.001 equal to, this is 1. Now let's take so we know this is nothing but this is phi of 1 minus phi of minus 1. Since we can, this is the normally distributed, this variable is a normally standard normal distributed, so this is this. So and we know that phi of 1, we know that phi of 1 plus phi of minus 1 is 1. So from that we can write it 1 minus phi of 1, so it becomes 2 phi of 1 minus 1, and this is 2 into 0.84134 minus 1, this is 0.68268. That's all. That's the answer of question number 8. Now let's move to the next question, that is question number 9. Question number 9. So now we're gonna solve the question 9. So question 9 is following. Excuse me. Suppose x follows standard deviation, standard normal distribution, standard normal distribution, then the distribution of y equal to e to the power x is. Okay, now let's see what is this. So first we're gonna calculate the cumulative distribution function. So cumulative distribution function of y at some point, suppose x is this means the probability that y less than equal to x. This means probability of e to the power x less than equal to x. So this means actually probability of x less than equal to log of x. Now we can calculate the distribution fy, sorry, the PDF of this function is derivative x with respect to small x. So this is derivative of a probability of x. So this is, sorry, so these actually the cumulative distribution function of x at the point log small x. So ddx of fx log small x. Now suppose log x equal to z, so ddz of fx at point z into dz dx, and this is the nothing but the the normal distribution again, standard normal distribution with variable z, and dz dx will be 1 over x. So this is 1 over x, and this is 1 by root 2 pi e to the power minus z square by 2. And what is the value of z square? 1 by x root 2 pi e to the power minus log x square by 2. So this distribution is nothing but this is log normal distribution. Log normal distribution. Now let's calculate its mean. So to calculate it means, let's first see what is the generating function of the random variable x. So what is the generating function? F of x at point t is the expectation of e to the power tx. Let's calculate it. So we know that it is minus infinity to plus infinity e to the power tx, and x distribution of the x, what is the distribution of x? 1 by root 2 pi e to the power minus x square by 2 small dx. So that means 1 by root 2 pi minus infinity to plus infinity e to the power minus half x square minus 2 dx 1 by root 2 pi minus infinity to plus infinity e to the power minus half x square minus 2 dx plus t square. So minus, if we minus, we have to plus t square by 2. So actually add t square by 2 and subtract minus t square by 2. So if we take this part out, because integration with respect to x, so 1 by root 2 pi e to the power minus, so plus t square by 2 minus infinity to plus infinity e to the power minus half x minus t square tx e to the power t square by 2, and this part minus equal to plus infinity to the power minus half x minus t square dx. Now if I choose y equal to x minus t, this is t square by 2 1 over 2 pi minus infinity to plus infinity e to the power minus half y square ty. So this part is nothing but 1, because this normalization condition. So integration over whole area is 1. So basically to the power t square by 2. So this is the generating function. Now here what is our if you see here the new random variable y is e to the power x. So this is similar to the generating function, only here t is equal to 1. So expectation of e to the power x, what it will be nothing but at t equal to 1. So if we put t equal to 1, so this is nothing but moment generating function of x at t equal to 1. So this is nothing but half, e to the power half. Now let's see what is the value of y square. So non-central second moment is mu 2 prime is e y square, so it is expectation of e to the power 2x. This is nothing but again this is moment generating function at t equal to 2, so let's put it, so e to the power 4 by 2 t square by 2, so t square. Now what will be the variance? Variance will be mu 2 prime minus mu 1 prime its square, that is e square minus, this is actually mu 1 prime, so this is e to the power half, so this is e, so if we take common e minus 1, so that means this is a log normal distribution with mean e to the power root e, so mean is root e and standard deviation is e into e minus 1. So that is the answer. Now let's go toward the question number 10. Let's move towards the question number 10. This is the question number 10. So assume that the maximum price of a commodity on a given day has a normal distribution with mean mu and variance sigma square. The shortest interval that has probability 0.95 of including the maximum price for this commodity. So we have to calculate the short interval has the probability including the maximum price for this commodity. We have to calculate the value of such that suppose that x is the price that distributed normally with mean mu and standard deviation sigma square. Now we have to calculate what is the has been this is, that means we have to calculate that the value, the shortest interval that has the probability 0.95 of including the maximum price for this commodity. So is we have to calculate interval if the price is normally distributed, then in which what is the range at means if I purchase that commodity, what is that rate within which I will get the commodity with probability 0.95. So that when we have to calculate that range, so we have to calculate a range. Since these distribution normally distributed, and normal distribution is symmetric around its mean, so that's why we have calculated this. So mu is the next less than equal to mu plus k is 0.95. We have to calculate the value of k. Now we can this by mu minus k by sigma mu minus k by sigma is then equal to x by sigma. Sorry, do one thing. So this means p, if I subtract with minus mu with every term, we'll get minus k less than equal to x minus mu is then equal to k. It's 0.95. So this is probability minus k by sigma less than equal to x minus mu by sigma less than k is 0.95. So this is nothing but this is z. So this is phi of phi of k by sigma. So phi of k by sigma minus phi of minus k by sigma, such that this is 0.95. So this is again we apply the rule phi of so we know that phi of x plus phi of minus x is 1. So if I apply that here, so phi of k by sigma minus 1 minus phi of k by sigma, that is 0.95. So this is 2 k to phi of k by sigma is 1 plus 0.95. So this is phi of k by sigma is 1.95 by 2. So what is the value at which the cumulative distribution function is? From the table we'll get that this k by sigma equal to 1.96. So this means k equal to 1.96 into sigma. So the answer is, therefore the required shortest interval is mu minus 1.96 sigma to mu plus 1.96 sigma. So that's it. So that is the answer of the question 10. So that is the end of today's session. So that's all.